Okay, so we're going to talk about what's called an infinite geometric series. So now we don't have a finite number of terms. Well, we have two different kinds. First of all, we could have a geometric series like this. 2 plus 4 plus 8 plus 16. And it's just going and going and going. So if you look at the terms, it's like 2 to the first plus 2 squared plus 2 cubed plus 2 to the fourth plus so on and so forth. Okay, we can write that with summation notation. K equals 1 to infinity, so there's no upper bound, it's just going to infinity. And we can represent the explicit formula 2 to the k. All right, now there is a common ratio here. The common ratio is 2. So if you take any two terms and divide them, 4 divided by 2 is 2. 8 and 4. 8 divided by 4 is 2. 8 and 16. 16 divided by 8 is 2. Okay, so it's a common ratio. But these numbers are just getting larger and larger and larger, and when you add them up, the sum just gets bigger and bigger and bigger. And so this is not defined. This is said, the series is not defined. Series is not defined. It's said to be a divergent series. It's getting bigger and bigger. Okay, but now let's think about something else. Let's say we have a situation where you drop a basketball and it bounces up half the distance. And then the next time it hits the floor, it bounces up half the distance. And it keeps bouncing up half the distance. Well, what does that look like? Let's say the first time it bounces up 16 feet. Well, then the next time it bounces up 8 feet. And then the next time 4 feet. And then 2 feet. And then 1 foot. And then half a foot. Then a fourth of a foot. And it keeps going, right? That's the sequence, right? Okay, so if I were to add these up, that would represent the series, right? Well, does the basketball is it gonna bounce forever and ever? No, at some point the basketball's gonna stop bouncing up. There's a limit to how much it can bounce. Okay, and so this series approaches a limit, okay? In theory, I guess, well, it's still bouncing, you know, but in reality, it's not. So we can represent the sum. It would be k equals 1, and then to infinity, and this is going to be 16 times 1/2 to the r minus 1. So we get that from, it's a geometric series. Okay, so we get that from the formula for a geometric series. You can think about that if you go back and look at the formula for a geometric series. But notice the r here, that was supposed to be n, sorry, n minus 1. The r is 1/2. Okay, so this is defined. Series is defined. We can figure it out. We're going to show you how to do that in another video. Okay, but it all has to do with whether your geometric series is defined or not. It depends on r. So if geometric series is defined, then r has to be less than 1 but bigger than -1. It's got to be between -1 and 1. Another way to say that is the absolute value of r has to be less than 1. Okay? Then your terms are getting smaller and you can add them up. You can figure out what the series is going to equal, can be defined. Okay, so let's look at some series that they give us. Well, this first one, I'm going to take the first two terms. I don't know what r is, so I have to figure out r. r is 8 over 12. Which is, what, 2/3? Okay, but then I have to look at the next two terms to make sure that the ratio is 2/3. They don't tell me whether the series is geometric, so I have to see if it's geometric. Okay, so now I have r being 4 over 8, which is 1/2. Okay, this is not geometric. In order for it to be geometric, you have to have the same ratio. So we were like, okay, let's assume that there's a ratio, but when we tried to prove it, it didn't work. Okay, now let's try this one. So the r would be if it's geometric, 1/2 over 3/4, which you figure that out by going 1/2 times 4/3. 4/3, you have to multiply by the reciprocal, and that's going to be 2/3. Okay, now let's take the next two numbers and see if it works. R is 1/3 over 1/2, or 1/3 times 2 over 1, which is also 2/3. So yeah, they've shown us enough information. The ratio is the same. It's geometric. Okay, so it is geometric. A geometric series. Now, is R less than 1? Is R between 1 and -1? Yes. So this is defined. Okay, now let's go to the next one. So this is written differently with the summation notation, but we can figure out the first term. So 27 times 1/3 to the first power, which is 9. And then 27 times 1/3 to the second power. So I'm just figuring out enough terms to see if it's geometric. So that's going to be 27 divided by 9, which is 3. So let's do one more term. 27 times 1/3 cubed, which is going to be 1. Okay, so do we think we have a ratio? Here are the first two terms, 3 over 9. So R is 1/3. Here are the second two terms, 1 over 3. Okay, yeah, it looks like it's geometric. Is R less than 1? Or between -1 and 1? Yes. So 1/3 is less than 1 and bigger than -1. So yep, this is geometric and it is defined. Okay, now let's look at this one. Well, the first term is going to be 5 times 1. The second term is going to be 5 times 2. The third term is going to be 5 times 3, and so on and so forth. So I get 5, 10, 15. Okay. Yeah. Okay, so what's the ratio if it's geometric? 10 over 5, which is 2. Then what? So those are those two terms. What about these two terms? 15 over 10. Oh, that doesn't look good. That's 3 over 2. So this is not geometric. Yeah. Okay, well, then it's not an infinite geometric sequence. So, yeah. I think that's it for that video.